Hello everyone, my name is Helwe, and today I am presenting my paper, A Deep Learning Approach to Detect the Demarcation Line in OCT Images. So here is the outline of the presentation. First, I will introduce the problem that we are solving using deep learning. Second, I will briefly discuss the related work. Third, I will explain our approach. Then I will discuss the experiment and the result, and finally, I will conclude this presentation. So what is our motivation? So what we are trying to do is to develop an automated solution to detect the demarcation line in OCT images using deep learning. So here, for example, are two OCT images, one that has no demarcation line, and the other one has a demarcation line. So this is a cornea, and this is a demarcation line. And for ophthalmologists, detecting the demarcation line is very important because, for example, it can confirm the efficacy of the treatment protocols. So we proposed a deep learning approach to segment the area between the top boundary of the cornea and the demarcation line. Also, we developed a simple algorithm to extract the demarcation line from a segmented OCT image. So there are two reasons why we are tackling this problem. First is that the clinicians are currently obliged to go through many OCT images of the cornea to detect the demarcation line, which is a tedious and time-consuming process. And for this reason, an automated solution is needed. Second, to the best of our knowledge, no study has explicitly looked at the detection of the demarcation line in OCT images with the help of deep learning. So we just found one study that looked into this problem, but using image processing algorithm. And according to our evaluation, it is not really accurate. Okay. Most of the deep learning applications in ophthalmology are in the detection of diabetic retinopathy, in the prediction of age-related macular degeneration, and also in the detection of glaucoma. And like I said, we didn't find any work that used deep learning to detect the demarcation line in OCT images. There are only one study that focuses on the problem of detecting the demarcation line in OCT images, but using image processing algorithms. So now I will describe our approach. So to train a more robust model for image segmentation, we propose a semi-weekly supervised learning approach. In our approach, we make use of two different datasets, one which is a labeled dataset, and another one which is a weekly labeled dataset. So first, we train a teacher model using this labeled dataset. After training, we use the OCT images from the weekly labeled dataset, and we segment these images using our teacher model. After that, we compute the dice coefficient between the predicted data and the mask of the weekly labeled dataset. And we have to check if it is higher than a predefined threshold. So why we are checking for this condition? To choose the best instances from the weekly labeled dataset to later on train a student model. In our case, the student model has the same architecture of the teacher model. So after pre-training the student model with the best chosen instances from the weekly labeled dataset, we fine-tune this model using the labeled dataset. So now, our model segments the area between the top boundary of the cornea and the demarcation line. It is based on a modified version of the SegNet model, which consists of an encoder network with residual block followed by a decoder network. So now the use of the residual block has many advantages, such as enabling the flow of the gradient to propagate effectively and to provide the model with iterative view of the features. Now, to be able to extract the demarcation line from an OCT image, we propose a simple algorithm that takes as input a segmented OCT image. So algorithm use a function from OpenCV called find contours to find the largest contour, which should be, in our case, the area between the top boundary of the cornea and the demarcation line. Then the algorithm search for the extreme left bottom pixel and the extreme right bottom pixel in the largest contour and check for their x coordinates. If the x coordinate of the extreme left bottom pixel equal to 0, and if the x coordinate of the extreme right bottom pixel is equal to 539. And the intuition behind this condition is that the demarcation line follows the same curvature of the top boundary of the cornea, which should begin at x equal to 0 and end at x equal to 539. Because the width of an OCT image is 540 pixels. Now, to create our datasets, we retrieve OCT images from an OCT imaging system Cyrus high definition SDT OCT scanner. We built two different datasets, one which is a labeled dataset and another one which is a weakly labeled dataset. So in the labeled dataset, it was labeled by a medical expert and checked by another one. It consists of 5,893 OCT images and their masked images. It was split into threefold as follows: 60% for training, 20% for validation, and 20% for testing. For the weakly labeled dataset, it was annotated by two non-experts in medical annotation, and it consists of around 27,000 OCT images and their masked images. So here are some examples of the datasets. So during the annotation, when there is no demarcation line in OCT image, so the masked image is represented as a black image. So now, based on the validation dataset, the optimal configuration for the teacher and student models are trained for 100 epochs with early stopping. The dropout value used is 0.2. The optimization algorithm used is Adam with a learning rate of 0.001. So the batch size used is 16. So now the result. As we can see from the table, the image processing approach has the lowest dice coefficient with around 0.58. And our approach is the semi-weekly supervised SegNet with residual block, which was trained using a labeled dataset and a weekly labeled dataset, has the highest dice coefficient with 0.90, which is higher than the other approach that we tested that were trained only using the labeled dataset. So now to conclude, we created a labeled dataset for the detection of the demarcation line in OCT images. We propose a semi-weekly supervised link approach for image segmentation, and we propose an algorithm to extract the demarcation line from the segmented OCT images. And according to our results, our model outperformed all other fully supervised models. For future work, we plan to investigate deep learning solution to this problem on other types of OCT images, and also we plan to apply our approach to other ophthalmology applications. Thank you for watching.